So this is how you would have solved number 3. So I set it up as 7 squared plus x squared equals 18 squared. You could have also said x squared plus 7 squared, same thing. Then I evaluate those square numbers, so 7 squared is 49, 18 squared is 324. Subtract 49 to the other side, I get x squared equals 275. So for 275, I'm looking for perfect square factors that simplify. And so that would be 25 times 11. And the square root of 25 equals 5, thus giving us x equals 5 square root of 11. So let's go ahead and try number 4. Number 4 looks like this. So we're still trying to solve for x. In this case, though, we have 2 of the same x value. So it's going to be slightly different in how we solve it. So first, let's remind ourselves of the formula. Excuse me. Let's substitute in our values. So I have x squared plus x squared equals 12 squared. Okay. Now, there's not much I could do with x squared, but I can't add x squared and x squared together. So it's 2 the same thing. So 2x squared equals, and I'm going to simplify 12 squared as 144. Then my goal is to solve for x, so I'm going to divide by 2 and get x squared equals 72. Then I'm going to take the square root of both sides, and I want to find a factor and see if 72 simplifies, which it does. So 72, the factor of 72 that would simplify would be 36 times 2. And the square root of 36 equals 6. So the answer is 6 square root of 2. Okay, and that's how you solve for a missing side length. The next thing we're going to talk about is called Pythagorean triples, or Pythagorean triplets. Okay, Pythagorean triples. Okay, what Pythagorean triples are is a set of non-zero whole numbers that satisfy the Pythagorean theorem. So what is an example of a Pythagorean triple? Well, the first example of a Pythagorean triple is 3, 4, 5. Okay. 3 squared plus 4 squared equals 5 squared. Okay. 3 squared is 9, plus 4 squared which is 16, and 5 squared which is 25. And 9 plus 16 is 25, thus giving us a Pythagorean triple. Okay. So a Pythagorean triple has to be whole numbers that are non-zero, just meaning it can't be zero, that satisfy the Pythagorean theorem, meaning that when you substitute those values in, it becomes a true statement of the Pythagorean theorem. So the question you're going to practice is this a Pythagorean triple? Okay. Does the set of numbers form a Pythagorean triple? So, for example, five, 11, 12. Okay, does the set of numbers form a Pythagorean triple? Okay, well, the question that you may be asking is, how do I know which one to set up with which? Well, remember, c squared always has to be the longest side, which means it is the largest number. And Pythagorean triples are always listed in smallest to greatest. So we're going to add the two smaller numbers squared to see if it equals the largest squared. So for example, 5 squared plus 11 squared, does it in fact equal 12 squared? Okay, go ahead and check that question and I'll come back to you.